Hello students. We learned in class 9 various constructions in geometry using compass and ruler etc. like angle bisector, perpendicular bisector of a line segment, constructing a parallel lines to a given line, some constructions of triangles also, and also gave their justifications. In this chapter, we shall study some more constructions like division of given line segment, similar triangle to a given triangle, and tangent to a circle from external point. Let us see the first construction, that is how to divide a given line segment into sections in a given ratio. Construction 1. But before knowing about the division of a line segment, let us know what line and line segment means. As you know, a line is a collection of points along a straight path, which extends to both the directions without endpoints. Here, AB is a line, which does not have ending or starting point. It is indicated by arrows. Whereas, a line segment is a part of a line between two endpoints. As you can observe here, PQ is a line segment, having P and Q as endpoints on the line AB. Similarly, ray is also part of line, such that it does have a fixed starting point, but has no ending points. Now, let us take up our construction to divide a line segment in given ratio. Given a line segment AB, we want to divide it in the ratio m:n, where both m and n are positive integers. For the sake of understanding, let us take m is equal to 3 and n is equal to 2. Students, note that m and n can be any integers, not necessarily 3 and 2. So, let us see steps of construction. Step 1. Draw any ray AX making an acute angle BAX with AB. Step 2. Draw 5 equidistant points on ray AX. Students, can you think why we choose 5 points and nothing else? Since we have to divide AB in the ratio 3:2, the number of points to be located on AX should be equal to m plus n, that is 3 plus 2, which is equal to 5 points. To draw these points, take the compass and taking A as center, draw an arc on ray AX with a suitable radius and name it as A1. Now, take A1 as center and draw second arc with the same radius and name it as A2. Similarly, draw 3 more arcs in a series on ray AX and name them A3, A4 and A5 respectively. Thus, we have 5 points A1, A2, A3, A4 and A5 on ray AX, so that AA1 is equal to A1A2 is equal to A2A3 is equal to A3A4 is equal to A4A5. Note students, here choice of distance is random. Only be careful about the fact that distance should be appropriate length. Don't take them too small so that they cannot be drawn with compass, or too big that parts go beyond the given ray. Step 3. Join the point B of the line segment AB to A5 on ray AX. Can you think why? Again, the reason is same. Since we have to divide AB in the ratio 3:2, we select 3 plus 2 is equal to 5th point. Students, if we are given ratio 3:5, then we will join B to 8th point. Step 4. Draw line A3C parallel to A5B, intersecting AB at point C. I am sure you already know how to draw parallel lines, but by chance, if you don't, let us quickly recall it. With A5 as center, and any suitable radius, draw an arc. It cuts AX at M and A5B at N. Measure distance MN. Now, with MN as radius, draw another arc on A3 such that it cuts AX at point Q. With Q as center and same radius, draw an arc cutting the previous arc, its cut arc at point R. Now, when we join A3 to R and extend it towards AB, it cuts AB at C. So, this is how we draw A3C parallel to A5B. Students, recall that if two corresponding angles made by transversal of two lines are equal, then those lines are parallel to each other. Here, we used same principle. We made angles A3C is equal to A5B. If you observe that they are corresponding angles when AX is taken as transversal. Thus, our lines A3C and A5B are parallel. Again, observe this line. A3C divides AX in two parts, such that there are three equal segments between A and A3 and two equal segments between A3 and A5. Thus, AA3 is to A3A5 is equal to 3:2. And therefore, corresponding points of A3, that is C, divides AB in the same required ratio, that is 3:2. Therefore, AC is to BC is equal to 3:2. But now, question is, how dividing AX divides AB in required ratio? Let us justify our construction. So, let us see how this method gave us the required division of line segment. If we observe the diagram that forms after construction carefully, we find two triangles. Triangle AA3C and triangle AA5B. Also note that A3C cuts two sides of triangle AA5B at points A3 and C. Also by construction, A3C is parallel to A5B. Therefore, AA3 upon A3A5 is equal to AC upon CB. Students, do you know how? Yes, you are right. By basic proportionality theorem, which states that for a triangle, if line cutting two sides is parallel to the third, then the ratio of two sides is equal. But by construction, A3 upon A3A5 is equal to 3 upon 2. Therefore, AA3 upon A3A5 is equal to AC upon CB is equal to 3 upon 2. Or AC is to CB is equal to 3:2. This shows that C divides AB in the ratio 3:2. Now let us solve one more example similar to this. Determine a point which divides a line segment of length 12 cm internally in the ratio 4:3. So we are given a line segment of length 12 cm and we are asked to determine a point which divides AB in the ratio 4:3. Since we are already given the length of AB, draw a line segment AB with length 12 cm with ruler. Draw any ray AR, making an acute angle, angle BAR with AB. As we want to divide line segment in the ratio 3:4, we will divide a ray AR into 3 plus 4, which is equal to 7 equal segments. For this, mark 7 equidistant points. A1, A2, A3, A4, A5, A6 and A7 on AR, so that AA1 is equal to A1A2 is equal to A2A3 is equal to A3A4 is equal to A4A5 is equal to A5A6 is equal to A6A7. Now join the point B to A7 as the given ratio is 4:3. Through the point A4, draw a line A4P parallel to A7B by making an angle A4C equal to angle A7B. As you can observe that there are 4 segments between A and A4 and 3 segments between A4 and A7. Thus, AA4 is to A4A7 is equal to 4:3. And since triangle AA4P and triangle AA7B are similar, AP is to PB will also be 4:3. Therefore, we can say that point P is the required point which divides AB in the ratio 4:3 internally. Students, remember, while doing constructions, always consider following point. First, the number of total arc on newly constructed ray is equal to m plus n, where m and n are numbers in the ratio just like in our examples. It was 4 and 3. So total arcs is equal to 4 plus 3 is equal to 7. Join last point to the end point of the line segment. Here we did A7 to B. For inner point, remember it will be the point same as that of the first number in the ratio. Like here, we took 4 as inner point as the first number of ratio is 4 in the ratio 4:3. In our next video, we will see one another method to divide line segment.